starting with the very first question on this review, all right, it says the diagram shows the pre-image of a rectangle in quadrant 1 and the shaded image after a transformation. Is the transformation a rigid or non-rigid motion? Why? So, in order for it to be a rigid motion, it has to stay the same size and shape. Those are the only two requirements. So on here, do those stay the same size and shape? No. So no. And reason why? Not the same size. It's the same shape, right? It's still a triangle, but it's not the same size. Not the same size. Now, other things that really don't matter, all right? Would the direction it faces matter for a rigid motion? No. Again, there's specific rigid motions, like a translation, that has to stay facing the same direction. But then, reflections and rotations do not. So make sure when you answer these types of questions, you're putting an answer that gives a correct explanation as well. Not just the yes or no part, but also a correct explanation. Majority of the test is multiple choice. Number 2. We have segment AB has coordinates of 2, 1, and B has coordinates of 0, -5. After a composition, the image of A prime is located at -6, 3. Which mapping makes segment AB congruent to segment A prime, B prime? Now, the question sounds really complicated. But do you need all the information they gave you? No. You didn't need to know that there is a composition happening. It doesn't tell you anything about the other transformations that are going on. It just wants to know from the original, the pre-image, to the final image, which one of these would correctly map one onto the other. Now, in order for it to be a rigid motion or a congruent transformation, you would have to have values that were not multiplied or divided. If you see multiplication or division in this type of notation, what's going to happen to your figure?
It's going to change size, right?
Going to change size. So right away, looking at those answer choices, you can't use A because it's multiplying. You can't use D because it's multiplying. They're out. Now, this can't really be asked in a non-multiple choice type of way because there would be multiple possible answers. So on here, we're down to 2 choices. You need to look at the coordinates that they gave you and identify which one would correctly do the transformation shown. So you have point A, which would now be at A prime's location. Do you need to know point B at all? No. But if you use point B instead of A, do you think the answer would be there? Probably. It's probably the other answer. So again, make sure you read the question because, again, you're given A and A prime. So, take the 2 and the 1 and plug it into your equation. So for B, if I took 2 and plugged it in, I'd have -2 minus 4. And for the Y value, I'd have 1 plus 2. I just plugged it into that equation. So my new point would be at, well, -2, -4, that gives me -6. 1 plus 2, that gives me 3. Is that where A prime should end up? Yes, it is. So B is the correct answer. Now, if you checked C, so you can check it as well, just to double check and make sure that it doesn't also work. But this is not a select all that applies type question. We plug in the 2. We have 2 minus 6. We had 1 plus 8. Those are 2 values that we just plugged in, right? So, 2 minus 6 is -4. 1 plus 8 is 9. Is that the correct coordinate? No. So, C doesn't work. Again, it didn't come to the correct location. So, make sure first you're making sure it's a rigid motion. And then second, check the point and see if it gives you the correct coordinate for the prime value. Yes?
I thought when you put a negative in front of an x, that was multiplication. It's like saying -1 times x.
It is, yeah.
I thought we could use
Okay. So you can't multiply or divide by any value that isn't 1. Because if you multiply by 1, does it change the size? No. One will keep it the same size. Now, it might change like the direction it's facing if it's a negative. But the fact that it's 1, it's not changing anything. So if you have a number that's either larger than 1 or less than 1, it's going to change your size. So here, I see where you got that though. All right. Number 3. This one, it's a little tricky. You have to look at it and figure out, all right, could you take one of the two images that's given to you and ever get the other image just by a rotation? So on here, if I took, here, I'm going to use the transparency just to help explain this a little bit. This one, could I ever get this image?
No.
Yeah. This one can be done through a rotation. Because if I trace this here, right, and I rotated my paper, this triangle and that triangle now the same thing, right? Yeah. Now, where's the point of rotation? It doesn't matter. The point of rotation would probably be somewhere way out here. Yeah, it's close, but not quite. So, again, it's not asking you anything about where the point of rotation is. It doesn't matter. But if you can get the original image onto the other one, then it's a rotation. If it doesn't map directly onto the other one in some way, can't work. So if I had to flip my paper over to get that image, that's not going to work. Only through a rotation. So say this little Pac-Man looking shape here. Could I ever get that one to map directly onto that one just through rotating my paper? No. Because if I rotated this so that it looked more like the other one, you'll notice the big N is on the opposite side. It won't line up. So that one doesn't work. So that one doesn't work. A worked, B does not. What about C? C is a yes. If I take that and I rotate it, basically 180 degrees, I get that same image. So that would correctly give me a rotation. What about D? No. And again, if you just look at one of the two images and rotate that one, if I was to rotate so that it was on the other side, it doesn't match up the correct long piece with the short piece, right? And it doesn't work. So this one's wrong. Again, only through a rotation there. Number 4. You got a question there?
If I get one of those clear pieces of paper, can I use it on the test?
No. You won't have one on the FSA, so no. I'm not giving you any for the class.
So how would you know, like, without using the...
Transparency, what I would recommend, you have a pencil, right?
Yeah.
Take one of the shapes, shade it in so you know which one you're looking at. All right? And then look for, could I ever get an image where the triangle would be in that position? So keep your eye on the one that you shaded. There it is. Right? That's the image that we're trying to come up with. If I use this one, let's say I shaded this image. So do I ever get an image that looks like that, where I have a short piece and then a longer piece? So if I rotated this around, I can see that the shaded piece is the opposite of that. It's long and then short. Right? But again, if you just want to either like shade it in or outline it so that you're just watching one of the two images and comparing it to the opposite shape that was originally there, that would be one thing that you could do easily. You get a separate sheet of paper, yes. You're not going to get a clear sheet of paper. He asked for a transparency. I'm okay with you having a scratch piece of paper. Yeah, I just need to collect it. In fact, you will have a Scantron, which, again, as long as you don't write on the bubbles, if you write in the blank space, that's fine. It'll work. All right. Number 4. A triangle with vertices, and it gives us the vertices, is translated by the following function. What are the vertices of the image? So essentially what I'm doing to each one of these points is I'm adding 5 to the x value and subtracting 2 from the y value. So if I take negative 2 comma 1, when I do this transformation, I'm plugging it straight into this equation. So I'd have negative 2 plus 5 and 1 minus 2. So where did I end up? Negative 2 plus 5 is 3. 1 minus 2, negative 1. That would be my first answer. All right. So then I do the same thing with the next one. So that was the first point, right? The next point, I have 0, 8. So I start off with 0, 8, plug it into my equation. I'd have 0 plus 5 and 8 minus 2. So my next point would be at 5 and 6. And then if I do the same thing with the last one, so I have the point 3, 0. We're going to do 3 plus 5 and 0 minus 2. 3 plus 5 is 8. 0 minus 2, negative 2. Those are my answers for my new points. Now, there's a very good chance that on a test, I would probably tell you that like this is, say, like A, B, and C. So then the points that you're actually finding there would be, this would be our point A prime, B prime, and C prime. I'd probably only ask you for maybe one of the points. All right. Any questions there? All right. Going down to 5. Which of the following are examples of rigid motion? So again, if you divide or multiply by a number that's not 1, it doesn't work. So which ones can I throw out right away? B and D. They multiply and divide by a number that wasn't 1. So those are changing in size. The other two, well, if you look at this, we should know what this one actually is. If you're just switching the x and y like that, that's a reflection over the line y equals x. So that is a rigid motion. So that's good. This one, we're just adding the value, and we're also subtracting value, but then we also have negative y. This is actually going to be a composition of transformations. But again, you don't even really have to know that. The fact is, we're not multiplying or dividing by anything, so this should work. Now, if you wanted to know what transformations are happening here, if I had an x and a y, and I then had x negative y, that'd be a reflection in the x-axis. So essentially, this got reflected in the x-axis, and then translated 4 units to the right and 4 units down. But again, we don't even have to know that to answer this question. We just need to know we weren't multiplying or dividing by a number other than 1.
What do you do when you reflect over y?
So if you reflect, on this one you're talking about?
Yeah.
So if you had a coordinate plane, that's line y equals x. If you do a reflection in that line, your x and y values switch. All right. I think we both gave out a sheet in class that looked like this. Yeah. Again, the notation on here is a little funky, but really most of the time you usually see arrows. I don't know. This was printed for New York, I think. I don't know why they put equal signs. I don't remember where I originally got this paper, but
Why is it so smooth? Is it that like you did a straight line, but you're doing a little thing, but it looks like...
So again, it should really be an arrow instead of an equal sign. Just saying that if you're doing this, right, then this is what's happening to it. But that's it. All right. But yeah, that's our notation for each one of those things. So this was the one that I was just talking about. And then other things that you should note, if you don't have this written down anywhere, for your x-axis, remember, x-axis is the same thing as the line y equals 0. The y-axis is then the same thing as x equals 0. Again, This is your x-axis. This is your y-axis. Make sure, because we could use either of those on the test.
So we just know the ones off the quiz or all of them?
Well, again, this is. I'm not going to straight up ask you these questions. I already quizzed you on this type of stuff, right? Can you use this to find different locations for points on the test? Yes. All right. I'll show you an example on one of these other problems. All right. So, all right. Is that clear as to? Okay. All right. Number 6. So there's 3 lines here, but actually, are there 3 different lines? No.
There's 2 different.
There's only 2 different lines. These 2 are the same thing. Maybe I might ask it in one form and then ask it in a different form on the test, so you probably need to know both formats. That's what I was just saying. So on here, really, if you know this information, you should be able to answer this problem, right? Because now this is being reflected across the y-axis. So what happens to our coordinate point if we reflect over the y-axis? The x value is going to change sign. So in this case, it becomes positive. So this would be positive 5, 3. Because if you make a negative, it becomes positive. Right? 2 negatives make a positive. On the next one, again, this is the same thing as saying reflecting the x-axis. So we're reflecting the x-axis, then it's going to change the y. So again, going back to my original point, the x value stays the same. The original x value was a negative, so it's staying negative. The y value is changing to negative, because again, the original value was a negative, so now it's negative. And that'd be the same answer for both of these, because that's the same thing. Whether it's saying x-axis or the line y equals 0, they are one and the same.
So what if it said x equals 0?
It says x equals 0, that would be the same thing as the y-axis. Remember, vertical lines are set equal to x. Horizontal lines set equal to y. Yes, because again, that the y-axis is a vertical line that goes through the x-axis at 0. Right? Just like the x-axis is a horizontal line that passes through the y-axis at 0. All right, on number 7. I don't know why this got blurry all of a sudden. All right, on number 7. If segment LM is translated along the vector, again, vector or directed line segment, those are the same thing. So it doesn't matter if it's called a vector or a directed line segment, same thing. I'm not positive, but I think on the test I may have used the word directed line segment. But again, vector and directed line segment, same thing. So,
The line segment.
if we're translating along that vector, this is just telling us that we are changing the x value by positive 4 and the y value by negative 6. So I have a graph. If you want to, you are more than welcome to use the graph. So we could take each point and move them 4 units to the right, because that would be positive 4 direction, and then 6 units down. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That'd be now L prime. Do the same thing with M. And it'd now be down here. Now, that's not the only thing though. It also tells you we reflect across the y-axis. This is your y-axis right here, right? So now take it and reflect over the y. This was 1 unit away, so we're 1 unit away on the opposite side. This is 1 unit away, so we're 1 unit away on the opposite side. This is now M double prime. So we have L double prime and M double prime Those are the locations. All it wants to know is what quadrant did we end up in?
3.
This is quadrant 3. Remember, you should know your quadrants back from algebra. This is 1. And then we go counterclockwise to name them. 3 and 4. So this is in quadrant 3, the final image. Now, do you have to use your actual graph in order to do that? No. Again, you could just use your notation to help you figure it out, right? If I took the original value that was at this L coordinate here, is at -3, +4. So that's my starting point. If I then was to do this, the translation, I'm adding 4 and I'm subtracting 6. So that'll give me a point at +1, -2, which you'll notice that's where it ended up. And then if you do the reflection, you make your x value negative when you reflect over the y-axis. This coordinate point is negative, negative. Negative, negative is in quadrant 3. You don't have to use the graph if you don't want to. You could just use your properties in this. I don't know why. They're both called function notation. But in this function notation, not the function notation that's in Springboard. Again, there's multiple ways to solve these problems. All right. On number 8. How many lines of symmetry? So in that first image, how many do you see? 1. There's just 1. Diagonally, going through the image this way, there is 1. On the second image, how many lines of symmetry does it have? 2. Both of them are diagonals. What about the smiley face? 1. Now, something very similar to this. And this one? 2. Now, this one is tricky. All right? This is a rhombus. All right? A rhombus does have 2 lines of symmetry. If this was a parallelogram, would it still have 2? So just a parallelogram, not a rhombus. No. So let me draw. I'll draw a parallelogram next to it here. If I had, again, a rhombus is a type of parallelogram. But if it's a parallelogram that's not a rhombus, how many lines of symmetry does that one have? 0. Tell me how you would reflect that. You can't.
Why not?
Because you wouldn't get the same image. Here.
It's like that little
Dang, so now we have to go back to the regular stuff. Go back
That's why you're eventually
Now, but yeah, there's no way that you can reflect that. All right. So now, number 9. Again, number 9. This one's asking which types of symmetry does it have. So does it have reflectional, rotational, or both? So if you look at the first one, what do you think? It does have both. And again, you can demonstrate by actually rotating the figure. If you need to, rotate your paper. See if you get the same image. Remember, you need to be able to get the same image in less than a 360-degree rotation.
What if it's 300?
Again, if it's exactly 360, it doesn't work. That only has one rotation, that's said not to have rotational symmetry if you're just getting the exact same image facing the exact same direction. You'd have to have, like on this one, I could go from point to point, right?
Yeah.
Each one of these is rotational symmetry. Now, it doesn't ask it on this question, but I'm going to add to this, just so that you have the knowledge. How would you find the angle of rotation for that rotational symmetry?
Divide 360 by how many times you rotate it.
All right, so how many actual points were there on this?
I was thinking about 7, 8.
There are 8 points, so 360 divided by 8
Or
gives us an angle of rotational symmetry of 45 degrees.
should I write that? Should I write that down?
You might want to, I don't know. Now,
What degrees is the test there?
I don't remember off the top of my head, actually, that question. I know I've had it in there in the past. I can't remember if I kept it on this version of the test. It may be on there, it may not. Shh, guys. That's what he just asked. Again, I do not remember if I left this on a test this year. I know I have asked it in previous tests. I do not remember if I asked for the angle of rotation or not. There's a lot of stuff in this chapter. I know I added some questions and took away some questions and changed a lot of values around from previous years. So I don't remember if I left one on there that has angle of rotation. It might be there. I can't remember though. All right. On this one, we also have the lines of symmetry. So it has reflectional symmetry. And it has many lines of symmetry that you could draw, because you could connect any of the points to each other, or you could have done through the gaps. So there is, in fact, 8 separate lines of symmetry too. All right. Yeah, there's a lot there. What about 2? Just reflectional. There's only one line of symmetry.
Wouldn't circle it, right? As the answer.
No, you're needing
Yeah, no. The answers here are for both. What, this?
I thought it said that.
8 lines.
Oh.
Again, the actual question, I'm explaining it in more detail than I need to, because maybe you might need it for the test. I don't know. Again, here, line of symmetry. So this has reflectional symmetry. It does not have rotational symmetry, so this would not work for both. All right. On number 3. This one does have both. This one works, because I can rotate it 180 degrees. Right? And I also have reflections, 2 separate lines of reflection. So this does have both. So 1 and 3 had both. Now, on the second part of 9 there, you have this lightning bolt. Can somebody tell me one way you could say this was rotated?
180 degrees.
180 degrees. Also negative 180.
You don't know what direction.
Either of those work, because one's going counterclockwise, the other's going clockwise. Right? Again, remember, guys, listen. Clockwise rotations go with positive or negative numbers.
No, negative.
Negative for clockwise. Counterclockwise are the positives. Right? So remember, here, I'm going to write a little chart here just to remind you guys of these things. Clockwise, counterclockwise. If you go negative 90, that would be the same thing as going positive 270.
Clockwise, negative degrees.
Your image 90 degrees clockwise or 270 degrees counterclockwise are the same.
Yes.
Right?
Is it because when you add the things
So then negative 180 goes clockwise. Positive 180 goes counterclockwise. They end up in the same place. Negative 270, which would be clockwise, is equal to positive 90, which would be counterclockwise. So again, if you're doing something like this on a test, you should have two things answered because two rotations should give you the exact same image. We good? Alright. No?
He's talking about your magic
I
trick.
see the negative because he turned
Are you
that
talking about his magic trick, Zach?
You never reveal a magician's tricks.
You get the exact same shape if you go the opposite direction, the opposite amount of degrees, right? So, again, 360 degrees make a circle, right? So if you took any of the negative numbers and added positive 360 to one of those negative numbers, you should get the positive value for the rotation. If you had a positive number, then you can subtract 360 and you get the negative value. Now, that's actually getting into trig though. That part of it. That's what we call coterminal angles. You guys will get there. Alright. So, a little extra. Alright. Go to number 10. On number 10. So, now, this one asks you to do two things. It wants to know what direction will the arrow be pointing after these two transformations. Now, if you want to, again, you can use your paper to help you out.
North.
All right? Right now, this is north, south, east, east, and west. Now, if you do the first one and rotate this 90 degrees about the origin, what way is it going to go? It's going to point down. Now, do these still apply in their current positions? No. Down would be the same thing as south. So currently, after the first rotation, it is pointing to the south. But we also were asked to reflect it in the line y equals 0, which is our x-axis. So what direction will this end up pointing in the end? North. It'll point up.
What? No, they're shook. No, they're shooked. Their whole
Again.
said no.
If you want to double check that, listen, we can use coordinate points to double check this, right? Look, if I took a point, again, I showed it first through just moving the image, but you can use coordinate points. So this point of the tip of my arrow, all right, is at, let's call that 0.5 and 2.5. Right? Then after the first transformation, the rotation of 90 degrees, they would switch and the y value, the original y value becomes negative. So we have negative 2.5 comma 0.5 for the tip of the arrow. Right? So on here, I could draw that. It'd be right there. And again, it'd be an arrow pointing down. Looks something like that. Right? And then the second part of this, reflecting the line y equals 0. Has your name on it? Alright, just stack it up in the back. Make sure you sign out. The reflection of this line y equals 0, we're changing the y value because this is the x-axis, right? So, change the y value. So now my point is here, and my arrow would point up. If you need to, you could do more than just the 2 points that more than the point that I used to help figure that out. But you would get an upward facing arrow. Yes?
So if it was reflecting the line x equals 0, would it still be facing south? Because it would be like...
If it didn't reflect, yes. But
If it reflected, say again.
Over the y-axis. Wouldn't it
It would still be facing down because then it'd be back in quadrant.
Hi, boys, I'm
So it's
9500.
x equals 0.
X equals 0 is our y-axis.
Yes.
Yeah, so what if it reflected over the y-axis?
It would
It would still be pointing down.
right?
Yes, correct.
Okay.
All right. All right. One other thing that I'll say real quick about this, because again, there are 6 other questions on the test, right? I would say the one that's the most different from what's on here is the question that's going to ask you guys to label your final figure. So if you're given an image with the original points like A, B, and C, then you need to be able to correctly label the final image with like A prime, B prime, C prime in the correct locations. So it'll tell you the transformations, and then you have to be able to label the image.
So it would be like, make it y equals 0, and then we would have to draw it.
So it'll give you, again, it's going to give you the original pre-image, and it's even going to give you the image, the final image, and it's going to tell you what transformations took place. All you have to do is label them.
Oh, what transformation happened? And what do we label it?
You just have to label it with your primes.
What's prime?
So like, if, like on here, for example, here, I can make this an example. Guys, quiet, shh. Here. If I called this point that I had labeled here A, right? Then this point here would be A prime. This point here would be A double prime. If I had another current point, say this point here, this is my, let's say I call this one B to begin with. When I rotate it, this would now be B prime, and this would be B
Prime.
double prime. And again, you need to have it in the correct location. All right? All right. Question, yes.
So what would we have to label?
The points, the vertices. It's not going to be an arrow. It's going to be a different shape, but it's going to have you label points.
What question would you advise us to study the most?
Again, every question on here correlates to something on the test. So you need to study all these questions. Because, again, like I said at the very beginning, there are 17 questions on the test. There are 11 questions on this sheet. Every single one of these is represented on the test. So there are only 6 other questions that aren't represented by this review. So study this, and you should do very well on those, at least those other 11
Are you
questions.
sure? It's really good.
All right, I think your hand was first, and then you guys in the back. Say again? Vertices of points, yes. All right. Test is out of 100, yes.
I thought this better.
Yeah?
I know you were saying something about perpendicular, but I know
Yeah, I can go through that diagram real fast. What page was it on?
That's what I do when I get tests.
Oh, wait. Shh. All right. The question that she's asking is about a reflection not on a coordinate plane. You need to know you need to know how to describe that you have a reflection and why it is a reflection, right? So on here, if I was to draw, so this line, or this point to this point, and connect them, these points are equal distant to the line of reflection. The line of reflection will act as a perpendicular bisector to any segment you draw between corresponding points. So on here, these two, again, that perpendicular distance from each other to their line of reflection is equal. So again, on each one of these, the distance from the vertices is equal to the line of reflection. So it has to be the same distance away from the line of reflection. Oh, sorry. She had a question, and I'll come back to you. Something like that could be on the test.
study,
When you
or
label
the chapters.
the first time you do the color.
No, like, so you're questioning that, like,
After the label.
Yeah, I don't know how I labeled it last time. I drew it on the board last time. I didn't make it colorful.
Doing nothing.
Yeah.
You don't have colors, you have to indicate that they're different.
I'm not going to make you draw anything like that on a test.
Yeah, I get that, but like, it's like